Okay, friends, so now here comes the data mining part. What we're going to do for the remainder of today is look at a few data sets and see if there appears to be a correlation. Data mining, I keep using this phrase, data mining. Um, all data mining is putting data sets together to see if there is a somewhat logical or somewhat apparent correlation. So data mining looks for correlations. It mines for correlations, M-I-N-E-S for correlations. So here's an example of two data sets that I slapped together not that long ago. All right, there we go. So I've intentionally left the axis labels unlabeled because I want you to just look at this, and I want you to, after I get done talking here, press pause, and what do you think? Is there a correlation? Press pause, and let's come back. Okay, so depending on what you're seeing here, you might say to yourself, well, okay, maybe there is. If I back up enough, it looks kind of like this BMI body fat list, if you think about it. I mean, it kind of looks like it, right? Here's what I'm seeing. I'm seeing blank space up here. And I'm seeing not a whole lot of blank space down here, but still some blank space. I see a mass of blue points right here. So since they're clustered kind of in this area, you can even kind of see how I'm circling them with my mouse, and I'm making kind of an oval, and the oval is a little bit tilted. It almost looks like there's a bit of an upward trend. It's a bit messy. I'm not gonna doubt that it's a bit messy. You've got some data points that are very far off here, but it looks to me not so much like there's points everywhere on this graph, but they are definitely kind of clustering right about here. So one way to interpret this, and I want to emphasize the fact that data mining is often as much art as science. You'll learn more tools in later stat classes, but right now I'm just trying to get you to look at these data sets to see if correlations do appear to be there. So I'm looking at this data set right here, and I'm saying, there might be a slight positive correlation, slightly positive. It might not be very strong, but it might be a slight positive correlation. And just if you're interested, the data you're actually looking at are a bunch of students, I got the source here for you if you're interested, trying to see if there is any correlation whatsoever between their high school GPAs and how they did on the math section of the Scholastic Aptitude Test, the SAT, scatter plot of SAT math versus high school GPA. So every one of these points is a student. Like that point right there is a student who got about a 3.4 GPA and scored about a 725 or 730 on the SATs. Okay, this student also scored about the same on the SATs, but has a bit lower GPA, maybe a 3.2 or so. Okay, you can see there's quite a bit of variation in the data sets. This is why I mentioned that there isn't a whole lot. It's not a very strong correlation if there is one at all. Notice all these points I'm pointing to right now all correspond to about an SAT score of about maybe 375. And these kids that are on the horizontal have GPAs everywhere from below a 1 all the way to up to a 4.0. So if it is a correlation, it's a loose one. But there appears to be maybe a slight correlation there. And now you're beginning to see how this can be art as much as science. You're just trying to look and get big ideas. Nobody's proving anything here. Nobody's proving that high school GPA is a direct predictor of how you do on the SAT. We're simply mining for correlations to see if any exists. Let's do another one in the next video.